All right, here we are, D. Dykstra with another video, and this is on integration with indefinite integrals. All right, so we're looking at the antiderivative now. So here's what we have. Let's look at some notation first of all. So we have this symbol here, looks like an S. It is the integral of, or the antiderivative of f of x dx is equal to capital F of x plus c. Now, what do each of those mean? Well, this symbol here, it looks like an S, is the integrand, right? Is the integrand. F of x is the function. So this symbol here, again, means we're going to take the antiderivative of the function. dx means with respect to x. Capital F of x is the result or the antiderivative of f of x, all right? C is the constant of integration. And anytime we have an indefinite integral, we're going to want to make sure that we tack on that plus c. The reason is because, as you know, when you take a derivative of a function and there is a constant there, that constant, the derivative goes to 0. So what we need to do is make sure that we put that constant back in if we were going to take the antiderivative, okay? So let's look at some basic steps here, some basic rules. If we were going to take the derivative of x, we would get 1, right? And interestingly enough, if we take the antiderivative of 1, we get x. So basically, the antiderivative is the undo of the derivative. So here you have a function, and you have the function, and if I'm going to take the derivative, it's like going down a layer, the way we represent it a lot of times in math. And if I'm going to take the antiderivative, I'm actually going to move up a scale because we're now looking for an area of something. We'll get into that later, but that's essentially what we're doing. All right, so the derivative of x to the nth power, if you recall, we brought the n down, multiplied it by the x, whatever number was in front of the x as well, and we then reduce the power of n by 1. Now, for the integral of x to the nth, now we're going to do is we're going to take the nth power and add 1, and we're also at the same time we're going to divide that x by n plus 1, and then we're going to add c. So again, this is what we call the power rule, and the power rule states that if we have the antiderivative of x to the nth power, that will equal x to the nth power plus 1 divided by that nth power plus 1 as well. We'll look at an example of that. Derivative of sine is cosine. Antiderivative of sine is negative cosine plus c. Derivative of cosine is negative sine. Antiderivative of cosine is positive sine plus c. Derivative of tangent is secant, and of course the antiderivative of secant is tangent plus c. And derivative of e to the x, well, that's still e to the x, and the antiderivative of e to the x is e to the x plus c. The derivative of ln of x is 1 over x, and the antiderivative of 1 over x is ln of x plus c. All right, so there you have some basic rules and steps to follow. You might want to write those down. And now let's look at an example. Example number 1. We're asked to find the antiderivative of, let's square it up here a little bit more, antiderivative of 3x dx. Now, here I rewrote it as 3x to the first power dx, where n is equal to 1. And now we can take the antiderivative. That's going to be 3. Remember, it's a constant, so we just kind of leave that alone. X, 1 plus 1. And then down in the denominator, we're going to take the 1 plus 1. So that ends up being 3 times x squared over 2. And finally, we get 3 halves. We can bring the 3 halves out. 3/2 x squared plus c. And that's basically what you do. You just add 1 to the power, and then make sure you divide the denominator by that power plus 1 as well. All right, let's look at another example involving some trig. So here we're asked to find the antiderivative of 2 sine x dx. Well, in essence, 2 stays the same. And what is the antiderivative of sine x? Well, it's negative cosine. So we take the negative cosine, the dx drops away, bring the negative out front, and we get that to equal negative 2 cosine x plus c. All right, that is indefinite integrals and some basic rules and steps and some notation for you. So hope you enjoy. Have a great time. Talk to you soon. D Dykstra out. Peace.